In the lower 48 U.S. states, the public is largely aware that a series of active volcanoes exist in the west-central portion of 3 states ranging from Washington to California. Here, well-known volcanoes include Mount St. Helens, which catastrophically erupted in 1980, Mount Hood, which erupted as recently as 1866, and Lassen Peak, which erupted during World War I from 1914 to 1917. And yet, while these systems compose a portion of the 20 active volcanoes which make up the United States portion of the Cascade Range, which itself stretches for 600 miles in length, these are not the only potentially active volcanoes located in the lower 48. So, why are not just the Cascades the 25 active volcanoes outside of the Cascade Range in the lower 48, including in Colorado, New Mexico, Arizona, and Idaho? The answer is that there are actually more than a singular volcanic province in this region which allows volcanoes to erupt in a set area, with the actual total being 9. This video will briefly outline each of these regions, some of which overlap in certain areas. For example, 5 volcanoes are located on the raised Colorado Plateau, but only 3 of these, Colorado Plateau specifically, Markagunt, the Uinkaray Volcanic Field, and the San Francisco Volcanic Field, can owe their existence purely to an unusual phenomena referred to as a lithospheric drip. Since the lower crust in this region is unusually dense and thick, material pooled in the lithospheric like a drop of sap before dethatching from the surrounding lithosphere. Then, large amounts of hotter material in the mantle rushed upwards to fill the empty space in what previously a section of lithosphere, and this motion pushed the crust upwards. At the same time, magma intruded into weak points on the uplifted plateau, forming scattered volcanic fields on the surface. San Andreas Fault shifting to the west, there are actually 3 other provinces located within California which cause volcanoes to exist other than the Cascade Range, which starts around Lassen Peak and heads northwards. Here, the simplest to explain is the San Andreas Fault Zone, which as a major plate boundary serves as a path of least resistance for magma to intrude into. Since the Pacific Plate and North American Plate are sliding against one another in an uneven manner, sometimes what are known as pull-apart basins form. 2 such pull-apart basins allowed volcanoes to form, specifically the Salton Buttes and Clear Lake. In the case of Clear Lake, it is not the San Andreas Fault itself but rather a strike-slip fault related to its motion. Walker Lane, however, while the San Andreas Fault accommodates the vast majority of motion associated with the aforementioned tectonic plate collision, a series of faults in eastern California